Now we are going to discuss the concept of bounded wildcard. So earlier we have discussed that type parameter can be bounded, and we have discussed one example on this. In a similar manner, wildcard arguments can also be bounded, and a bounded wildcard is especially important when we are creating a generic type that will operate on a class hierarchy. So consider one example. So assume we have a class 2D. So in 2D class, so consider we have two instance variables x and y to store the values of x coordinate and y coordinate. Now consider we have another class that is 3D. So 3D is a subclass of 2D. So we can write like this: 3D extends 2D, and assume it has three instance variables x, y and z to keep track of or to store the x component, y component and z component of a coordinate. Now consider another class that is 4D, and 4D is a subclass of 3D. So we can write 4D extends 3D, and it has four instance variables like x, y, z and t to store the values of x, y and z coordinate of a point, and here also we are considering another one that is t for time you can consider. So I am not writing in detail like int x, y, z like that and constructor, so that are not I am writing for, just I am providing one overview. So now consider we have another class that is coordinate, and this coordinate is a generic class. So we have one class coordinate, and this is capital, and this coordinate is a generic class, and it also uses the concept of bounded type. So you can write t extends 2D. So here you can observe the objects of this coordinate class are of only three types. That means it can be like this: coordinate either 2D, or we can write coordinate 3D, or we can write coordinate 4D. So the objects of this coordinate class are of three types only, and these are like this: coordinate 2D, coordinate 3D and coordinate 4D, because this coordinate or this generic class coordinate uses the concept of bounded types. Now consider we have one method that is print xy, and print xy method we are planning to define, or we are defining this print xy method in the coordinate class. So here print xy method is going to work for this 2D, 3D and 4D objects, or you can say this print xy method is going to work for all the objects of type coordinate 2D, coordinate 3D and coordinate 4D. So we can write like this: we can write coordinate, and it is going to work for any type of objects, and assume the parameter name is C, and here this C is capital. So, and we can write the statements here to print the values of x and y, because print xy is going to work for all the types of objects like this. Now consider another method we want to define here in the class coordinate. So assume the name of the method is print xyz. So here you can write print xyz is going to work only for this coordinate 3D and coordinate 4D, and print xyz method is not going to work for the objects of type coordinate 2D, because you can here see for coordinate 2D objects the z component is not there. So here we can write or restrict the arguments to types 3D and 4D only. So 3D and 4D only. Here we want to restrict the arguments to type 3D and 4D. So for that we can write this wildcard that is represented by the question mark, then extends 3D, then assume the name of the parameter is C. So coordinate, then question mark extends 3D. So this concept is called as bounded wildcard. So it allows the objects of 3D and 4D only. That means it allows the objects of actually coordinate 3D and coordinate 4D. Like this, here you can see it is going to work only with the objects of coordinate 3D and the objects of type coordinate 4D, and coordinate 2D is not allowed. So if you want to invoke this method print xyz on the objects of type coordinate 2D, so it is going to throw a compilation error. Now consider another method, that is print all. So the name of the method is print all. So here we want to print all the components, that means x, y, z and t. So it is not going to work for all types of objects, it is going to work only for the objects of type 3D. So you can write like this, coordinate, so this is capital coordinate, then this question mark extends 4D, then angular bracket close and name of the parameter may be C. And here we can write the statements for, here also you can write the statement to print xyz component, here also you can write to print the xy, print all components. And this method, this last one, print all method, is going to work only with the objects of type coordinate 4D. And here this concept, here you can see question mark extends 4D. Using this we are making an upper bound 4D for the objects that can be passed as an argument to this method print all. So this concept is known as bounded wildcard arguments. So we will discuss this example in more detail and write the program on this. So let us consider a class and the name of the class is 2D. So consider we have a class and class is 2D and it has two values, one is x, another one is y, and we can use a constructor for initialization. So we can write 2D int a, int b, and the value of x is a and the value of y is b. So this is the end of constructor. Now we can write another class 3D that is a subclass of 2D. So for this we can write like this. So we can write class 3D, that is a subclass of 2D. So for that we can write extends 2D. So class 3D is a subclass of 2D. Then here one extra variable, that is z, and we can use the constructor 3D to initialize the values. So here we can write int a, int b, int c, and we can call the super, or we can call the super class constructor using the keyword super. Then pass the values a and b, then z equal to c. So the z value here is initialized with the c, and a and b are passed to the super class. That means a value becomes x and b value becomes y. Now the end of the constructor and end of the class. So here end of constructor, end of class. Okay. Now we can write another class, that is 4D. So we can write class 4D, and that is a subclass of class 3D. So we can write class 4D extends 3D. So THREED, and we can take an integer variable, that is t, and we can constructor like this 4D and int a, int b, int c, int d. Then using the super we can pass a, b, c to its super class constructor. Then we can write t equal to d. Then end of constructor, end of class. So I hope up to this it is clear to everyone. So we have a class 2D and two values are there, x and y, and we are using the constructor 2D to initialize x and y. So this is the end of constructor and this is the end of class 2D. Now we have another class 3D, that is a subclass of 2D, and here we have one extra variable, that is z. Now we are using the 3D constructor to initialize x, y, z. Similarly we have another class 4D, that is a subclass of 3D, and this is the constructor to initialize x, y, z and t. Now we will write another class like this. We can consider the class name is coordinate, class coordinate. So this is capital because class name starts with capital letter. So class coordinate, so it has one type parameter, that is t extends 2D, like this. Now we have one array of t, assume this is codes. Now we can use the constructor to initialize. So this is capital in constructor, it is the exactly same as the class name. So coordinate t and assume the object name is ob, and here codes is equal to ob. End of constructor, then end of class you can consider. So here you can observe that this coordinate specifies a type parameter bounded by 2D. So we have earlier discussed bounded types and we are implementing this here. So this means that any array stored in this coordinate object will contain objects of type 2D or one of its subclasses. So this one can be an array of type 2D or one of its subclasses. Now suppose we want to write a method that displays the x and y coordinates for each element in the codes array of a coordinate object. So all types of coordinate objects have at least two coordinates, that is x and y. So all types means here we are considering only 2D, 3D and 4D because we have written 2D, 3D and 4D. So all the types of coordinate objects have at least two coordinates because 2D have also x and y, 3D have also x and y, and 4D have also x and y. So we can use a wildcard in the method to print the values of x and y, and the method you can consider like this. So let us consider the method static void. So we can write this method in this class only, so no issues. So now concentrate on this method only. During implementation we can write the method inside this class, or you can use a separate class, no issues. Now static void, and assume the method name is so xy, and it is going to take one coordinate object, of unknown type. So it may be 2D, it may be 3D, it may be 4D, and assume the reference name is C. Okay, now we can print so for int I equal to 0, because this is an array, so we need to start from 0 to the end of the length or end of the codes dot length. So I less than c dot codes dot length, then I plus plus. So system dot out dot println, insert I am writing SOP. So we can write C dot codes of I dot x plus some space plus C dot codes COO-RDS, because we have already defined COO-RDS. Here you can see where we have written here only COO-RDS, that is an array, and we are using this one C dot COO-RDS, then I dot y. Now this is the end of the method. So here you can observe this one, this space we are printing for a space or for a gap between this x and y value. So it is going to directly print the value of x, directly print the value of y, not their sum, because of this string or because of this space only. So here you can observe coordinate is a bounded generic type that specified 2D as an upper bound. So here we have written coordinate is a bounded generic type that specifies 2D as an upper bound. So all the objects that can be used to create coordinate object will be arrays of type 2D or of classes derived from 2D. So this means this array is of type 2D or the classes derived from the class 2D. So this means this array can be a 2D array or can be a 3D array or can be a 4D array, or we can say this array is of type 2D or 3D or 4D because T is bounded by 2D. So in this way, so xy can display the contents of any coordinate object. So any coordinate object can be displayed, or any coordinate display can be used as a parameter here, because all the coordinates 2D array, 3D array and 4D array have x and y values, and for any object we are writing this wildcard argument. Now suppose we want to write a method to display the x, y and z coordinates of 3D and 4D objects. So we cannot write like this. So if we want to write a method to display x, y and z coordinate, so we cannot write like this. So let me write this one. So based on this we can write static void, assume the method is show xyz coordinate this wildcard coordinate wildcard and see. So here for int I equal to 0, I less than c dot codes dot length I plus plus system dot out dot println c dot codes of I dot x plus some space plus c dot codes of I dot y plus some space plus c dot codes of I dot z plus this one, or you can remove this last space here, it is not required. Okay, then end of this method. So here you can observe so xy and so xyz both are same except here the method is different, method name is different, it is show xyz and here xy, and here we are adding one extra component that is z, and rest are same. And here we can observe this method is not going to work because the coordinate, this wildcard type means any coordinate object, any coordinate object. So for any coordinate object there is no z value. Any means it may be 2D, it may be 3D, it may be 4D. So because not all coordinate objects will have 3 coordinate x, y, z, and 2D objects have only x and y. So we cannot use 2D objects here. So or our objective is to print the values of x, y, z of coordinate 3D and coordinate 4D objects, and at the same time we should prevent the coordinate 2D objects to use this method. So in this scenario we can use the bounded wildcard arguments concept. So how to use the bounded wildcard arguments concept here? So in place of just simple wildcard like this one, like this question mark, we can write this. So I am removing this part and I am writing this one here, that is this one question mark extends 3D. So we can remove this part also for simplicity. So previously we are writing only question mark, now here we can write question mark extends 3D. That means this method xyz, this method xyz can be used by the objects of 3D and the subclasses of the 3D class. That means in particular by the objects of 3D and 4D. So if we want to pass, or if we want to use, or if we want to invoke this show xyz method using a 2D object, then the compiler is going to throw an error, or we can say the compiler is going to prevent the 2D objects to invoke this method, and it is going to allow the 3D objects and 4D objects to use this show xyz method, or to call the show xyz method. So here it is one example of bounded wildcard. So a bounded wildcard specifies either an upper bound or lower bound for the type argument. So in this example we are putting an upper bound using this extends clause. So this bounded wildcard enables us to restrict the type of objects upon which a method will operate. So in this example the extends clause establishes an upper bound for the wildcard arguments. So if we want to call show xyz with a coordinate 2D reference, so this results compile time error and ensures type safety. So in general, to establish an upper bound for a wildcard, we can use the extend clause like this. So this one wildcard extends superclass. So this is used for the upper bound. Now similarly, to specify the lower bound for a wildcard, we can use the super clause. So like this we can write this one super and subclass. So here subclass specifies the lower bound. So only classes in this example, only classes that are superclasses of subclass are acceptable arguments. So we have discussed that we can use extends and super clause to define the bounded wildcard or to set the limit of wildcard arguments. Like we have discussed, we have written here class 2D and two instance variables of class 2D are there, and these are x and y. We are using the constructor to initialize x and y. Similarly, we have written here class 3D, then we have written here class 4D, and we have taken another class coordinate that is of parameterized type, or we can say class coordinate that is a generic class. Then we have defined class test, and in the class test we have written show xy method, and we have also defined the show xyz method like we have discussed earlier. Then we have also written show all method in the same way that we have discussed. Now we are going to write the main method. So we can write like this: public static void main string args. Now we are going to create the objects of 2D. So for that we can write 2D and assume we are creating one array. So assume name of the array is TD. So here we can create the objects like this: new 2D, and assume some elements are like 0 0 like this. So here you can observe we are using the concept of array initializer. That means we are defining the array elements and we are creating the array at the same time. So TD is an array of type 2D, and here we are creating the objects of type 2D using this new operator. So following this we can write some other objects. We can see, so it is 0 0, so let it be 5 7. Next another one, assume it is 5, or we can 4 and 6. So assume 3 elements are there. You can take any number of elements, no issues. Now we are going to create one object of type coordinate 2D. So 2D and assume the name of the object is tdlocs, or in particular it is the name of the reference variable. So we can write new coordinate, and here we can write 2d twod, and we can write td. That means we are going to pass the array. So we can write here system.out.println, just copy this one. So we can write here contents of tdlocs, contents of tdlocs, that means the 2d locations. Okay, so so here we can call the method xy. So xy tdlocs. Okay, so now similarly we can create the objects. Suppose consider, I'm just copying this one, and we can create the objects of 4d. Suppose you can consider. So here it is, we can write for 4d and assume name is fd. So it is assume 1 1. So 4 elements required. So I am writing here 1 1 1 1, or we can say 4 parameters or arguments required. So 5 7 4 3. You can write here, you can write 4 6 8 10. Okay, so coordinate, here it is 4d, for 4d. So assume it is fd locations. So new coordinate, it is 4d, and assume here it is fd. So content of fd locations. So we can write so xy fd locations. So here we can call so xyz also, so xyz. Okay, so we can also write so all, and you can create the objects of type coordinate 3d. So you can write, but for simplicity I am doing this one. And so let us check how it works. Okay, so 4d equal to new 4d we have to write. So as we have copied, it was a mistake, because 2d objects cannot take 4 arguments. So it is for 4d. Okay, so now we'll check. Okay, successfully compiled, no error. Then Java test. So it is printing the contents of td locations, xy coordinates 0 0 5 7 4 6, contents of fd locations, xy coordinate 1 1 5 7 4 6, xyz coordinates 1 1 1 5 7 4 4 6 8, like it is showing. Now you can observe, suppose if I write here so xyz and we pass td locs or tdlocs, so you can observe it is going to throw an error. So javac test dot Java. So it is throwing an error, incompatible types, coordinate 2D cannot be converted to coordinate this one. So why we are getting this error? Because TD locations or object of type coordinate 2D cannot have Z component, and in the show XYZ method here you can see, so the coordinate objects extended 3D. So here the objects are of type 3D or the subclasses of type 3D. That means 3D and 4D are allowed, and here we are writing the objects of coordinate 2D, so it is throwing an error. So I hope this one is clear to everyone. Now you can observe, can we convert this method and use, instead of wildcard, can we use the generic parameter t here? So we can write here t extends coordinates coordinate and void so xy, so tc. So now we will check whether it is working or not. So java c test dot java. Okay, so it was due to the previous error, so just make this one. Okay, otherwise it is okay. So it is compiled successfully, then java test. So it is showing the same output. So previously we are using the wildcard arguments. Now here we are using generic types for method show xy. So here you can observe. So earlier we have discussed about generic method and generic classes. So similar to generic method and generic classes, we can also write generic interface. So consider this example. Here we have written one interface of generic type. So here consider box is an interface, and it has one method, that is add item. Now we need to implement this interface using a class. So assume the class myBox implements this box interface. So we are writing this one like class myBox t implements box t. So a class that implements a generic interface by default is interface. So here myBox by default is generic. So a class that implements a generic interface by default becomes generic. So here myBox is also a generic class because it implements the generic interface box, and in this way we are writing the myBox class. So class myBox t implements box t. Now here we have one item or one variable that is of type t, and we are defining the add item method that is given in the interface. So here public void add item, so it is accepting t item, or it is accepting item is of type t as parameter, and simply we are writing this dot item equal to item, that is we are initializing the item value with this method. Now similarly we are writing another method, that is get item, and get item returns the value of the item. So this is the generic interface, a simple one, and this is the class that implements the interface. So it is only simple two methods. One is add item, that is written here or that is given here, and one extra method, that is get item, we are writing in the MyInbox class to get the value of item. Now we can write a main class or we can write another class where we want to write the main method and use these interface, or in particular use this MyInbox class, or create the objects of MyInbox class and call this add item and get item methods. Now we are going to implement this one and see the result. So here you can see we have written the interface box like we have discussed. Then we have written the class MyInbox that implements the interface box, and this class MyInbox also we have discussed, and we have written in the same way that we have discussed just now. Now we have taken another class, that is class test, and here we are writing the main method, so public static void main. Then we are creating the objects of MyInbox, and as MyInbox is a generic class, so we are creating MyInbox integer and one object intbox that is of type MyInbox integer, and we are adding one item 25 or one integer value 25 using the add item method. Similarly, we are creating another object of type MyInbox string, and we are adding Java using the add item method that we have already discussed. Now we have written system.out.println intbox.getItem. Similarly here strbox.getItem, and getItem method here we have defined, so it simply returns the value of item. So now we will check how this program works. So successfully compiled, then Java test, so it is showing 25 and Java, because and this one displays 25 and this one displays Java. So I hope this one is clear to everyone.